I think that the simplest way of solving an absolute value inequality is to solve the equation that would correspond to that inequality. For example, I could take this inequality and rewrite it as an equation 4x plus 3, the absolute value of 4x plus 3 equals 19, and then solve that equation to find what I call critical values that can be plotted on a number line, and then we can determine which parts of the number line should be shaded. In this problem, if I change to an equation for the time being, just to get the critical values, I could break this inequality or this equation into the two possible cases. Either 4x plus 3 would equal 19, or 4x plus 3 would equal the opposite of 19, and then solve each one of those equations. If I subtract 3 from both sides and divide by 4, I get x equals 4. If I subtract 3 from both sides and divide by 4, I get negative 22 over 4, which is a negative 11 halves. What I have are critical values that can be plotted on a number line, separating the number line into intervals, an interval less than negative 11 halves, an interval between negative 11 halves and 4, and an interval greater than 4. And now I want to see which of those intervals work as far as values in those intervals work in the original problem, so I can determine my shading. So I'm going to try some values, try a value in each one of these intervals. For example, 0 falls in the interval between negative 11 halves and 4. I'll try 0 in the original inequality and see if it makes it true or false. If I plug 0 in for x, I get 0 plus 3, which is 3, in the absolute value, which gives me a positive 3. That is less than 19, so yes, I will shade this middle interval. If I try something greater than 4, let's say 5, I would get 20 plus 3 is 23. The absolute value of 23 is still 23. That's not less than 19. Or not less than 19, so no, I don't shade that interval. And if I try something less than negative 11 halves, let's say I try something like negative 10, I would have negative 40 plus 3 is negative 37, but the absolute value of that would make it positive 37, which is not less than 19, so no, I don't shade that interval. Also, looking at the inequality symbol, it's strictly less than, or it's not equal to, so I will not include the negative 11 halves and the 4 as part of my solution, but I will shade between. In interval notation then, my answer would be negative 11 halves to 4, not including the negative 11 halves and not including the 4. If you try the values of 4 and negative 11 halves back in your original problem, you will find that those values make it equal to 19. For example, 4 times 4 is 16, plus 3 is 19. The absolute value of 19 is equal to 19. 19 is not less than 19, so I don't include that in my solution. But I do realize then, because it does equal to 19, I realize that 4 is a critical value. Same thing with negative 11 halves. If I plug negative 11 halves in, I get negative 22 plus 3 is negative 19. The absolute value of that gives me 19. That's not less than 19, so I do not include it in the answer, but it does show me that it is the critical value, or a critical value, for this inequality. Let me give you a problem to try. Pause the video. Attempt this problem. When you get the solution, come back to the video to check your answer. Once again, I want to solve this absolute value inequality first as an absolute value equation to find my critical values. So I'll change to an equation and then write my two cases, either 5x minus 11 equals 9 or 5x minus 11 equals the opposite of 9. I can add 11 to both sides and divide by 5. I can add 11 to both sides and divide by 5. And I get my two critical values, 2/5 and 4. Once again, those critical values separated my number line into intervals. Let me try values from each of the intervals. For example, let me try 0, which is less than 2/5. If I try 2/5, if I try 0 in the original inequality, I would have 0 minus 11 is negative 11. The absolute value of that would make it positive 11, which is greater than or equal to 9, so yes, I do shade this left interval. If I try something in between 2/5 and 4, let's say I try 2. 5 times 2 is 10, minus 11 is negative 1. The absolute value of negative 1 is 1. That's not greater than or equal to 9, so I do not shade the middle interval. And if I try something greater than 4, let's say 5, I have 25 minus 11 is 14. The absolute value of 14 is greater than or equal to 9, so yes, I shade the outside interval. My symbol is greater than or equal to, which means I do include the critical values as part of the solution. My interval notation would be from negative infinity to 2/5, including the 2/5, in union with 4, including the 4, off to infinity. Remember, we always use parentheses for infinity since we don't reach those values. If I try my critical values of 2/5 and 4 back in the original inequality, let's say I try 4 back in here, I get 20 minus 11, which is 9. Absolute value of 9 is equal to 9. That is true in this case, so yes, 4 is a part of the solution. If I try 2/5, I have 2 minus 11 is negative 9. Absolute value of negative 9 is 9. That is equal to 9. So yes, 2/5 is part of the solution. Also, it shows because they made the inequality equal, or showed that it was equal to the 9 when I plugged those values in, it showed that they are critical values. If we locate the critical values, then we can test any number inside the intervals. If we have the correct critical values, any number in an interval, if it works, then every number in that interval works. If it doesn't work, then none of them will work. And that's how we can determine our shading.